Right, hold on to your hats. This is probably the biggest walkie-talkie you've ever seen. This is a monster. This came through from Dom, my very good friend. He sends me lots of radios and gifts. Very kind of Dom to send me a little package with this radio, which I'll show you perhaps on the next video. But this is a big walkie-talkie. Now, this is an 80 channel 5-watt walkie-talkie. It's a high gain 80. Now, if somebody can point me to anywhere on the internet that's got any information about this radio, it's probably going to be too late, because I'm going to try and look at this myself, but I could find no information about this at all. Till I take it apart, I don't even know if it's AM or FM. I'm assuming it's going to be AM. It's Japanese made. There's a 40 channel version which I have seen on an eBay page, but I can find nothing about this walkie-talkie. So this will probably be the first time you'll have seen this, so we're going to take it out of the box. It's in very good condition and it's not working. It's dead, so we're going to try and get this going. So out of the case, the polystyrene case is in very good condition, and here you can see a battery substitute. This is your dummy battery. Now, I think what may have blown this up, as with a lot of these sets, is the fact that somebody has actually put more cells, put 12 1.5 volt cells in this set and not used the battery dummy. So that's what often kills these sets. People don't read the instructions. So here we go. Here's the walkie-talkie. She blows. It's in very good condition. I thought I'd put it up next to a ruler. We'll work in inches. It's 9.5 inches there, look, or 240 millimeters. And it's certainly quite a beast in terms of thickness. Let's pop it on its side there. You can see in terms of thickness we've got a PTT there as the swivel attachment for the strap. We've got our battery case on the back side, and then on this side we've got a channel light button which you can press to light it up, a speaker and phones attachment, and we've got an external antenna connection there, which is cool. High-low power switch, and then the power and the charge connections there for the charger. This appears to be a brushed aluminium or steel, could just be sprayed steel, but certainly metallic. The back case, you can see there, is plastic. It's kind of got that textured finish to it. And we can see there the Made in Japan sticker. So let's take the battery box off and check for any signs of corrosion. I can't see any signs of corrosion in there at all. Now what I will do is, because Dom has sent me some NIMH rechargeable batteries. Now I'm going to be a bit careful with these, because if any of you have used NIMH batteries before, you can get up to as high as 1.5 volts per cell when these are fully charged. They're typically 1.4 volts. So even with 10 of those at 1.4 volts might be too much for some of the chips inside this radio. So I've got to be really careful with that. So I'm going to resist putting the batteries in it just for now. Let's just give you a close-up. I'll show you what we've got here. We've got a signal strength meter. Don't know if that's a proper meter, we'll find out. We've got squelch controls on the front here, volume off on, channel select, and there we go. Look, we've got a 4-pin external mic socket as well, which could be quite useful. Being 4-pin such as this, that's a screw-on 4-pin connection, but it certainly makes for a rugged type connector, and there's a switch there for switching it between external and internal, okay, as you will. So yeah, I think we need to take it apart, don't we? But first off, we'll put a power supply onto the back of it and see if we can power it up at 12 volts. And when you're looking at a battery tray like this, if you're not sure which is your positive and negative, you're looking for pairs. These batteries are always in series in these types of radios. So if you look at the pictures of the batteries on the radio and establish first we have a positive tip there. Okay, so on this one, if I use my meter and we have a short between these two pins, we know that this is the loop around, this is your series connection. Okay, so if we follow this back down to this end and we check continuity between this pin and this pin, and we know we haven't got continuity there, we know that this is our negative here. Okay, so we know this is our base negative. This is how we work that out. So our cells are starting from the negative, going through this one and through this one. So we know that this is the positive 12 volts and that's the negative 12 volts. This is how you work it out. I mean, some of you obviously will know this, but I'm just pointing this out in case some of you don't. And it might help you if you just want a bench supply, you haven't got a big mound of batteries to test it with. Now I've got the radio switched on and we're just going to pop 12 volts on there. We've got it set for 0.5 amp on here, and as you can see, as I'm touching that, there's absolutely nothing happening on the radio, which is unusual, which may be something quite simple inside. Possibly it might just be something as simple as a diode or a wire off or something like that, because normally there is a bit of life and there's no. It could also be like a battery eliminator problem. It's got a power socket on here and a charge socket, and this would eliminate the batteries when the power is plugged in. So that's my first port of call, is to check our continuity from the on-off switch through this power connection here, because when you plug in the charge connector, I would imagine, or the power connector, it will disconnect the batteries from circuit. So that would be my first port of call. And so we'll do that, and I'll have to work out how this comes apart. And but these screws in the back here look favourite to come out first. And indeed, it is only those screws that hold the case on, and we can see there we've got our chop out circuit for that socket. So first thing I'm going to do is to unplug this from the board here. This board looks fairly unmolested. Very often handhelds can have moisture ingress, but this one looks in very good condition. Antenna connections look fine there. A little bit, looks like there's been a little bit of maybe some corrosion of some kind on the board there, possibly, but we'll see. So let's take this cover off here and examine this circuit to see if we're getting our signals through to where they should go. Right, we've got our positive connection, but when we do the same with the negative side, on the negative side we don't have any connection. Now there does appear to be a compression mark on the insulation. If I can zoom in there, I can see there, so it might simply be just continuity is lost. But as we look at this and how it tracks into this little module here, it's not a common ground. The negative going off to the battery comes from the other side of the board, so I think we're probably as well to take that little board out if we can do that carefully. I don't want to damage that board. There's some little inductors on there, look a little bit delicate, but I'm sure I'll get to the bottom of where that is. First off, we'll trace the connection back to the board to make sure that's good, and then we'll work back towards this plug. Yeah, so our negative wire is good coming up to the board, but it's not seeing the return on that lead. Now it may well be because the negative wire is being switched through this power connection here, so when we plug a power connection in, it's disconnecting this lead. Now you probably won't be able to see it down the barrel of that plug, but I can see by looking in there that there is corrosion in there. So we shall work on that first, on that principle that this is where the actual problem is, because there's not really anything to go wrong on this board here that I can see. Possibly those chokes might have gone open circuit, I suppose, with overcurrent. That's a possibility, but there looks to be a fairly decent sized inrush or limiting resistor there, some kind, maybe a self-resetting fuse maybe. So I think we'll have to take this board out, and that'll be easier for it to work on. And of course, when we're using our cleaning sprays, we don't want to get the cleaning sprays onto these plastics. Depends on your cleaning spray, but it can sometimes cause problems. Right, so as suspected, the culprit is within this module. The negative feed from the battery comes up to this choke here, and then it goes through that choke, through the auxiliary contact of the power switch, and then back out to the negative lead. Now that part of the circuit is working. The contacts are a bit dirty, but they're nonetheless okay. but this inductor here is open circuit. There's no connection either side of it, so it's this little fella that's unfortunately poorly. Now I might be able to rewind that. It's possible. I do have some coils off of old sets that might be able to help me there. It's a fairly thin wire on there, unfortunately, but I'm sure I might have something lying around. I mean, obviously we could link it out. Not ideal, but it's only there for suppression really. But it's a lovely old vintage set, this. So, and Dom's a great guy, so I'm going to make an effort to try and repair that properly. Yes, and there's our culprit, the poorly inductor. Now, if I had one of these expensive microscopes everybody on YouTube seems to have at the minute, I could probably zoom in to see where the damage is on that coil. We're getting pretty close with my camera, aren't we? But there's obviously damage in there somewhere. It's open circuit anyway, isn't it? So let's unravel, count the windings, and see if we can do something with it. I think I might have some. Obviously, I need enamelled wire to do anything with that. So it's not a size inductor I've seen on any normal CB radio though. So chances of me having one like that, I know I haven't got one. I've not seen an inductor that small on any of my stuff. So anyway, let's unravel. Look at it, had just broken off as it entered the centre of the inductor. So we're okay now. There's the continuity. So we're good. And we could put this on the meter and just test its inductance. We've got a little meter here. We'll do that just before we put it back. So now we'll check for our continuity between there and the battery terminal. And we're good. So we know that's okay. We're just going to put some switch cleaner in that connection there, and then we'll tuck this back down in the case. And we'll actually, now we know that's good, we can do all of our tests across these pins. Now, bearing in mind that had gone open circuit, I have checked this to make sure there's no short circuit across these pins, of course, because it could have been an overload condition that caused that. And there doesn't seem to be any problem across these pins. We will current limit this though before we turn it on, so hopefully we should be able to get some activity out of this radio when we turn it over. And usually the external antenna jack appears to be a 3.5mm mono stereo jack, a 3.5mm mono jack plug. I do happen to have some of those on hand, so we shall make up a short coax lead with a PL259 on the end, so we can plug it straight into the test gear. We'll do that first and then come back to you. Now, I do have this wonderful box of adapters. I have even more in other drawers stashed away, and this is the beauty of doing this. You can save yourself a lot of time, because look what I found. Wonderful. So that should pop nicely into there, and we just pop our test equipment straight in. Okay, the moment of truth. We turn it on. We have no discernible volume at the moment. The microphone needs to be on internal, that's on remote at the minute. Have we got any crackle? I think there was something there, wasn't there? Yeah, I think there is a little bit of a hiss. Okay, and if we press the channel illumination button, we are getting channel 5. Okay, now the other thing I noticed upon power up, when we turn the power on and off, we're getting the, and we've got the pop on the speaker, so that's good. We've got our pop on the speaker, which indicates that our audio IC is okay. This switch might need a bit of a clean, so there might be a little issue with that, which might be giving us problems with volume, possibly. I can definitely hear a hiss there. There's scratchy volume, but I can hear a hiss, and I can hear the squelch cutting in as well. Let's just go ahead and go for transmit, see if we get any power come up on the meter. Oh yeah, we are. We're getting our voltage drop, so let's put our current limit up, because we're current limited at the moment. So let's put our current up to 1.5 amps, that should be enough at 12 volts. Okay, let's give that a try now on the power. There we go. So that's doing probably 2 watts, is it? Something like that. We can probably see it on the 2.5 watt scale. We're in the low power setting, mind. So we're doing just over 1.5 watt there. Let's pop it into high power. There's the switch for that there. Let's try that. I think we're going to need to go up the scales, aren't we? Oh no, it's about the same. It doesn't seem to make any difference, that. The higher the low power. Still drawing 0.5 amp on high or low. So that's something we can look at. Maybe the switch is a bit funny. Okay, so yeah, there's no high power at the moment. What does this do on transmit? Okay, that just goes to the right. And I still don't know if this is AM or FM. I presume it's AM. So let's get to channel 20 and see what frequency we're on. And there we can see we are on 27655. So in old money, and according to Del Boy's list, that is channel 20 is 27655 is high band. Okay, so the first 20 is on high band. So I wonder if the second 20 is going to be super high. So let's try it. As you guessed, high-low wasn't for power. Some of you probably already guessed that. High-low is the frequency selection. Okay, so we were on high band. Now we've moved it to low band. I sussed that as soon as I turned the channel display, because when it's a bit of a pain, you can't manually keep the channel on. You have to hold the button down. So we're on channel 20, but we've only got 40 digits on this display. We haven't got 80 on here, so it's only a 40-digit display. So now we should be on the mid band, your classic CPT. So 27205. So let's pop the President Randy on. We're on channel 20 on the Randy, and try keying up, and sure enough, there's our signal on the Randy. So we're good. So it's AM, it's mid and high band. 1 2 1 2 1 2 1 2 1 2. So we're getting modulation from the radio as we're transmitting, but we're not getting any reception as we're transmitting back with the Randy. We've got our volume up full. We're into the external speaker, and we're full power with the Randy. And we've got nothing on the signal meter. Well, that might not mean anything. I'm not sure if that's just a glorified battery meter sort of thing. So yeah, we've got not really any receive going on, so to speak. So it's transmitting, it's on bang on frequency. It's got the high and low channels, so we just have a reception issue here. So give this section a clean with IPA and reflowed some of the joints on around here. But we've still got no audio. I say no audio, we do have a very, very faint audio. Let me just detail that. We'll just put the power on, if you can hear that. Turn the power off. On, off, on, off. So we do have noise there. Now what we need to do, I would imagine on a set of this age, it's probably going to be a capacitor that's gone. The sound chip looks to be there. We could have a diode. We've seen that on the radio, handheld radio recently, haven't we? So we might have a diode off the antenna side. I took off far too many screws than I needed to. If you've got one of these, you're just looking for these side screws to take the front off. Okay, so you've got 1, 2, 3, 4, 5, 6. I took out a whole bunch of screws from the back side of the board, and you don't need to do that to get the front off. You just need to pull the knobs off. One of those was very tight. Pull all 3 knobs off, and then this top lifts straight off. So I've learned that lesson. I've got quite a few screws to put back in, but never mind. Okay, not that many of you I don't think are going to be working on this radio, because as we've already said, this is a very, very rare beast indeed. So I very much doubt any of you will get to see one of these unless it's this one. But nonetheless, I still wanted to record it because it's a part of radio history. Radio Museum hasn't even got any information on this at all. So let's have a little close look at see if we can. We've got no information on it. I can probably work out tune-up wise where most stuff is. There's your modulation transformer, of course, and I think these are our power transistors down here. So we've already cleaned the jack sockets there. Let's see if we can trace the audio around the circuit. It looks to be, I mean, you just look at those resistors, you can see how old the components are there. So my suspect would probably be a capacitor somewhere in the audio side has gone kaput. We'll find out where the audio IC is, and then I'll do some touch tests, and we'll perhaps use my signal tracers to see if we can pop a tone in from the tiny SA. We'll generate an AM signal, feed that into the radio, and see where it's disappearing to, and see if we can work out why we're not getting any audio out of the or very little audio out of the set. Right, that reference for the motherboard or the circuit board looked familiar, and turns out it's a Ham International reference, and this radio goes by another guise under the name of the Ham International 8040 Handmaster, and this circuit board is used within that radio. Very similar looking radio, different knobs, but the case is the same, badge is different, but it's probably a more popular radio than this one. But we have a circuit diagram, and this makes the absolute world of difference. So we should be able to go through in our usual fashion and identify all the components for the tune-up, but just at the moment I'm just interested in the audio side. So let me take a look and see if I can spot any possibly capacitors that might be causing this issue, and see if I can find the component within the radio. What we've got here is just a basic very sensitive audio amplifier, battery powered amplifier, and connecting up a capacitively coupled switch sensor probe. We can pick up the mild hiss. You hear that? Bit of a buzz on that, but there's no volume getting to this switch, so I'm pretty sure there's a problem on the output of this directly, because we're getting no output going through that switch at all, just a very faint hiss. So let's check that capacitor out, or both capacitors, or all capacitors. You know, set this age. They might look nice and shiny and nice, but you can't always just go on appearance. Let's give the PTT switch a bit of a clean. We've got the volume up full, and we can see just by touching the connection that we can see that there's no problem with the audio output driving the stage here. This is definitely a receive problem. I've checked both the VCO mixers and the 10.695, the 10.24 meg outputs of the two synthesizers there, and they're both working. They're both showing up. I'm using the SDR to check those. Very useful, the SDR, for that, and we've got signals on both. So I know the mixers are working okay, and we know the audio stages are okay. So I'm starting to center around the receive side and the crystal filter here. But what I noticed was, by attaching a lead to one side of the crystal filter, I was managing to get reception off of the on the radio via the President Randy, albeit a little bit deaf. So what I decided to do was to start taking a look at the board, and there does seem to be some rather glaring joint problems here, dry joints. I mean, that one there, I don't know if you can see, I can actually, let's get a prod on it, I can actually move it with the actual, let's get it to focus, come on camera, See that? You can see the crack around the solder. So what I'm going to do, I'm going to go around this section, because I just don't think there are any bad capacitors in this. They all look really good quality capacitors, and I just don't think it's that. Very useful having both the sniffer tool and this amplifier. This amplifier is so sensitive. Let me just show you this. If I switch it on, I just turn it on and I key up on the President Randy, you'll hear me through the amplifier. 1 2 1 2. So it's a very useful tool for tracing RF, and I can't remember if I did a video on that one, but I did a video on this one, which is also great for tracing faulty components. So let's whiz through this section with the soldering iron. I've got the pine seal soldering iron. If you've not seen a video on that, go and have a look at that. Cracking little iron that is. I'm going to whiz through that section there, and I reckon this might crackle back into life. Possibly, or we might have to change the crystal filter, and I think I got one of those in an old set somewhere we can use. So let's go through the soldering and see if it just what is something as simple as a bad joint. Hello, I decided to break this up into 2 videos because it was a little bit big for one. So join us on the next video, and you find out if this was indeed the problem, or if I managed to fix this radio. Let's say it was a little bit convoluted, but tune in on the next one, and you'll see our progress and how we get on with this lovely old vintage set. If you have been, thank you ever so much for watching. It'll only be a couple of days away, and you can catch up on the next episode. Thanks again, take care.